Okay, so we are moving on to 7.3. We are multiplying and dividing our rational expressions. So we are essentially multiplying and dividing fractions. So what we're going to look at here is, because we're going to be starting to have these fractions and that we can't have x or 0 in the denominator, how can you determine these excluded values when you're multiplying or dividing these two rational expressions? So first, let's just talk about simplifying fractions and why that works. So when you simplify 15/50, most of you would just divide by 5 and get your answer. But what you're really doing is breaking this down so that there's a common factor between the numerator and the denominator, and then the common factor of 5 between the top and the bottom can, as we like to say, cancel out, and you're left with 3/10. So what we're doing is we are factoring out or canceling out the common factors. So 24, if I think of a common factor, as I could break it down into 8 and 3 and 8 and 4, and then the common factor of 8 can be canceled out between numerator and denominator. So even something like this is A times C and B times C. C is the common factor, and again, factors multiply, all right? Let's make that little note. Factors multiply to each other, and terms add and subtract for one another. You're going to see me use that word. So anyway, this common factor, because C is multiplying, cancels out. So what we're going to see is something that looks like this. So my factors in this problem are 4 with x plus 3, and then down here x plus 3 and another factor of x plus 3. So what I can do is cancel out the common factor of x plus 3, not the terms. I'm not taking this x for this x and this 3 for this 3. It's a whole factor for a whole factor, so that when I'm done, I'm left with 4 and x plus 3. Okay? So big thing, factors multiply, those can cancel out. Terms do not cancel out. Anything that's adding or subtracting cannot cancel out. So let's talk about what you're going to do here. So simplifying, we're going to first start with simplifying before we go into the multiplying and dividing. So essentially what we're doing is just what we did at the top. So the steps we're going to take first is we're going to factor the numerator completely and the denominator completely. We have spent some time factoring. I'm not going to go into the very difficult versions of factoring. If it's pretty simple, I will just be showing you the factors. So first I would factor this. And so this numerator factors into x minus 3 and x plus 1. And then I would factor the denominator. It would factor into x minus 3 and x plus 2. And now what I want to do is start to look at, if I did want to graph this, and we just graphed this in the last chapter, where would I have some problems, as far as what wouldn't work in my walls and such. So I have to remember that this denominator can never be 0. I can't take a numerator and divide it by 0. So as far as this, when I talk about the domain and the excluded values, we identify the domain or the excluded values by looking in the denominator. And the denominator can never be worth 0. Okay? So what would make my denominator 0, and what I would worry about for my domain issues, these excluded values, and you're going to be seeing this a lot, is that x can never be 3 and x could never be negative 2. Those are pretty simple to see. So now that I've done that, what I can do from here is what we did at the top. I can cancel out the common factors. I'm not going to cancel out the terms. Anything that's added or subtracted cannot be canceled out. It's what's multiplying. So x minus 3 is a factor, it's multiplying to x plus 1. X plus 2 is a factor, it's multiplying to the other factor of x minus 3. So this factor can take out this factor, so when I'm done, I am left with a simplified version of x plus 1 and x plus 2. And if I graph this, it will look very similar to this, okay? We'll talk a little bit more about that in just a little bit. So I'm going to go to the top. So just a reminder, this is called the difference of squares. This turns into x plus 3. I'm factoring the numerator and x minus 3. The bottom one I am going to walk through this factoring. Since there are 4 terms, I'm just going to group them real quick. Kind of do the side work up here. So out of this I can factor out a 2 and x squared. And then 2x squared times what gives me 2x cubed, that's an x, and 2x squared times what gives me 6x squared, that's 3. So I'll need another x plus 3 here, and so what times x gives me 5x, or what times 3 gives me 15, that's a 5. So here's my factored denominator. X plus 3 just once, not twice, and 2x squared plus 5. So now what I want to do is, before I start canceling stuff out, is I need to look at my excluded values. So what's going to make that 0? That one's pretty simple to see. I would never pick -3. And then what would make that 0? So that one's not as easy to see. So remember, if you don't know what makes it 0, find a spot, set it equal to 0, and get x by itself. Subtract 5, divide by 2, and then try to take the square root. And as it turns out, you can't take the square root of -2.5. You can, but we get an error message or it's an imaginary number. And if you think about it, so what that means is nothing's going to make this set of parentheses 0, because no matter what number you take and square it, any number, positive or negative squared, is going to be positive. Take that positive times 2, you have positive, add even more positives to it. This is never going to become 0. It's just going to keep getting bigger and bigger. So my only excluded or domain issue is -3. But now what I can do is take out the common factor of x plus 3 and x plus 3. I'm not going to take this x for an x. And when I'm done, this is my simplified version. But again, when you look at domain issues, you always look at the original problem, the way it presents itself. There might be an easier way to look at it, to graph it, but you always look at the original version for domain. So when I look here, I can't factor the top. This is not a difference of squares. It's plus, not minus. So this can't be factored. And I can't take an x out for an x. These are terms. X squared adds to 4. 4 and x squared are terms. And you learned that in Algebra 1, the difference between a factor and a term. So this is it. So what would make it 0? Again, if you don't see, set it equal to 0, move the 4 over, take the square root of -4, and you're going to get an error message. You're going to get an imaginary number. And it's for the same reason. If you take any number, positive, and you square it, or negative and you square it, you get a positive number. And if you add even more positives to this number, it's just going to keep getting bigger and bigger. So here, there are no domain issues. It's all real numbers is what we used to write. Okay? So let's take a look at multiplying and dividing. So as far as multiplying and dividing goes, we're going to follow the same steps as simplifying, but just a little bit more work at the end. So we're still going to factor the numerators and the denominators, but you're just going to have a lot of numerators and denominators. So you got to factor everything. So this one, what we need to start doing is looking for a greatest common factor. So this factors out of 4x, and then I'm left with x minus 1. The bottom is a very simple factoring. I'm not going to go into how to do that. That's x plus 3 and x minus 1. I'm going to go to my next fraction, and that's x plus 3 and x minus 2. And then 4x, I mean, you could break it up into 4 and x, but otherwise we're going to leave it as 4 and x. So that's step A. Let's go to step B, figure out those domain or issues or excluded values. Look at the denominator. Never pick -3, 1, or 0, so I'm just going to put that over here. For my domain, I cannot let x be -3, 1, or 0. We can write them in any order. And it's not division, so we don't have to do that. We're just going to simplify or cancel out any of the common factors between the numerator and denominator. So x minus 1 multiplies to 4x. Factor, factor. This is a factor, this is a factor, 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 factor. They're all multiplying. So x minus 1 will take out 1x minus 1. X plus 3 will take out an x plus 3. 4x will take out a 4x, so that when we're all done, you're just left with x minus 2. Okay? Leave the answer as is. Sometimes you might be able to add some common like terms, but that doesn't happen here on E. Okay? So let's go to the next one. So first, let's just make that into a fraction. X plus 3, that's linear, you can't factor. On this one, so I'm going to leave that alone. Greatest common factor, I can take a 2 and an x out of both of them, and when I do that, I'm left with 2x plus 1. 4x squared minus 1, this is a difference of squares. It's 2x plus 1 and 2x minus 1, and then the 1. So again, look in your denominator. What would make this factor 0? If you don't see it, set it equal to 0. Subtract 1. Divide by 2. Get -1/2. What would make this one 0? It's just 0. So as far as my domain goes, I will never pick x to be negative 1/2 or 0. But now let's do our canceling out. So this factor of 2x plus 1, we'll take out this factor of 2x plus 1, and that's it. So what we're left with is x plus 3 and 2x minus 1, and in the denominator we're left with 2x, and we're just going to leave it like that. Okay? So what happens with dividing? So remember, in dividing, you don't actually divide by a fraction, you multiply by the reciprocal. And last year students, I don't know who taught them this, would say copy, copy, dot, turn it into a multiplication dot, and then flip-flop that one. So that's what that means. So first, again, before I do any of that, factor it, can't factor 5x. This, I can just take a greatest common factor of 3 out. Here I can take a greatest common factor of x out. And again, this is very basic factoring. This can turn into x minus 4 and x minus 2. So if I look at the way the problem is, you got to be really careful with domain issues because you have actually a lot of denominators. In this fraction, you have this denominator, and so I would never pick 4. In this fraction, you have these two, so I would never pick 4 again or 2. But if you think about it, this is a fraction, so this is a numerator, dividing all of this, so all of this is a denominator. So you also have to look over here for x and x minus 2. So I would never pick 2 for this one or 0 for this one. So for the denominator, we're looking in a lot of different places. Here, don't pick 4. Don't pick 4 and 2. I already have 4 written, so I'll just write 2. And then here, 2 is already written, but I'll add 0. And now that we're ready to do the math, I'm going to copy. I'm going to dot, and I'm going to flip-flop. And I'm going to wrap that one in parentheses. So now I can take out my common factors. X minus 4 takes out x minus 4. X minus 2 takes out x minus 2. And 5 is multiplying to x. So 5 is a factor and x is a factor. And this x was multiplying to this x minus 2. So these x's are factors. So when you're done with all of this, you just get 5. Okay? So let's take a quick look at this one. I want to talk to you about this graphing thing and about those domain restrictions. And this is just something to share. I want you to hear it because it does come up next year, and I don't want next year to be the first time you see this. So if you took this problem and you graphed it, or you took a simplified version and you graphed it. So this problem is just the one here. So we already did this, and the simplified version was x plus 1 over x plus 2. What you're going to see is that you're actually going to have the same graph. So what I've done already is I've put in the original problem, and here's the graph. And now what I'm going to do is put in the other version, the simplified version. Oh, I know it's taking a while, sorry. And I'm going to graph it. So you're going to see the red going over the blue. And they look exactly the same. But there is actually a big difference between these two. Because if you just looked at this graph, you would say, well, in the domain, x could never be negative 2. Okay? But if you look in its unsimplified... Okay, sorry, I got cut off there for a second. So again, if you look at its unsimplified version, what we did on the other side, this x minus 3 and x plus 1, excuse me, and then x minus 3 and x plus 2, when you look at the unsimplified version, we couldn't let x be 3 or negative 2. So I want to show you the difference of what happens. And you can't see it in the picture very well, unfortunately. But what I want you to look at is I'm going to go to the table and I'm going to show you what happens. So going to the table, and blue is the simplified version. So if you notice, we said that x could never be 2. I'm sorry, negative 2, and if you look, you're going to see you get an error message in the original, in the simplified version and in the original version. But when you go to the other one where we said x couldn't be 3, and you go to the simplified version, I'm sorry, the unsimplified version, you get an error message. But if you look at the simplified version, it lets it be there, because if you're just looking at this, it's saying that x could be 3. So what ends up happening, and you can't see it here, I'm going to take this out, this simplified version, that what's happening is that when it's graphing here, you know, it's definitely stopping at -2, and that's noticeable. But what you're seeing and what it looks like is that it's continuing at 3. And unfortunately, these graphing calculators don't let you see this, but what should happen is there should be, let me go on here. There should be like a little hole here in the graph where the graph just stops. It's discontinuous. It doesn't keep going. So there actually should be a little blip, but it's such a little blip that on the graphing calculator, sorry, you can't see it. So I just want you to be aware that there is something called a hole, and on your graphing calculator you won't see it, but it shows up here. Okay, and that's it. Those are the notes.